Hello everyone, this is a journey of me learning to build a RISC-V single cycle core from scratch as a beginner. So this is my journey of building a RISC-V single cycle core. Now I have actually built something that can run a C program on it from scratch. So few weeks back, I have posted in Reddit communities for help, asking for help and guidance on building this single cycle core. Actually, I have asking help for building this. So I have no idea how this CPU cores work, and I have asked for guidance and advice from peoples in Reddit communities. Got some, but not so much from the Reddit communities. But later I have figured out on my own to build this single cycle core with the available RISC-V official documentations and internet resources. So it was really challenging to get the resources from the internet because there is no proper resources in the internet. There are a lot of resources scattered across the internet, but not so collectively in a grouped manner. So after finding the resources, I have started my CPU design a few weeks back, like 1 or 2 weeks back, and from the last week I have been building this single cycle code. So this is a little documentation on my CPU core in my Notion page. So it is a 32 cross 32 core, and it has some basic instructions. Let me show the instructions. So I have followed the official RISC-V specifications for the opcode and ALU operations. So if you want to go with if you are using official RISC-V toolchain for compilation of your C program, you must go with the official specifications that are represented in their RISC-V documentation. So this is an important note. If you want to run your C program on the official RISC-V GNU, you have to make sure that you are using the official opcodes. So these are the supported instructions in my single cycle core. So these are basic instructions. There are a lot of instruction available, and for the complex designs, you have to implement all the instructions. But as this is my first complete design of a CPU, these are the supported instructions in my core. So I have had add, subtraction, and operation or operation, add immediate, subtraction, sub immediate, store, load, branch if equal to. So jump type instructions and U type instructions are available too. So these are the instructions, and I have used another set too. Like, let me show you. So these are the hex code that I have been generated using the RISC-V toolchain. So this is the code actually I have been building for the past week. So these are the modules I have been using, and these images are collected from the internet. And this is the C code that I ran in my CPU just now. So this is a very basic code, just addition code, but it has to go through a lot of instructions to just get the output in the register. So it will be coming out in the register 10. So this is the basic operation. It will be using the JAL OR operation, JAL OR instruction. So after doing this, let me go to the So for the compilation, I have used the RISC-V GCC. So I have installed it in my Linux and compiled the C code and turned it into my hex file. So my hex file looks like this, something like this. So after loading the hex file this is my hex file. After loading it here, I have just implemented this hex file into my instruction memory from the test bench itself. Not so complicated. So I just implemented from the text on test bench itself. Yeah. So with this, I have simulated the design, and yeah, this is a complex process. I cannot explain it with my words because just now I figured out how these things work. So after doing all this, my complete design looks something like this. Yeah. I have took the basic image from the internet, the background image, and I have added some other lines to support the extra additional instruction that I have added. So like JAL type and JAL R type, and that's the jump instructions and U type instructions. This is the design I have been working with. So yeah, that's it. This is the video of me developing a CPU core from scratch. This is a journey. So if you want something related about this, you can ask me in the comment sections. I will be posting the next video about or regarding that. So I'll be trying to upload videos on building the complete RISC-V core itself once I have been so familiar with it, because this is my first CPU design. Later, I'll be doing the pipeline version, and more on I'll be going with the ARM processes. So yeah, the SoC design is the ultimate goal. So you can ask whatever you want in the comment section. I'll be helping out people. And yeah, this is the channel for doing stuff like this VLSI and electronics. So next videos will be uploading soon. Stay tuned.